Rivers to reservoirs. A river might flow all the way to the sea, or it might flow into a giant lake called a reservoir. A reservoir is a lake that is used for storing water needed by people. The water you use for drinking, washing, and cooking probably comes from a reservoir. Some reservoirs are lakes created by nature. But nature does not always make reservoirs where they are needed, so some reservoirs have to be built. A wall is built across a river valley to hold the river back. The wall is called a dam. Water piles up behind the dam and fills the valley. Water flowing through a dam has an enormous amount of kinetic energy that can be converted into electricity. Making electricity. Some reservoirs send water to power stations for making electricity. Electricity made from water is called hydroelectricity. At a hydroelectric power station, water from the reservoir flows into a huge pipe called a penstock that goes through the dam. Some of the energy from water will be changed into electrical energy. Did you know? The biggest reservoir in the United States is Lake Mead. Part of it is in Arizona, and the rest is in Nevada. It contains enough water to flood land about the size of the state of New York to a depth of 12 inches, 30 centimeters. The Hoover Dam, between Arizona and Nevada, holds back the Colorado River. The water that piles up behind the dam forms a reservoir called Lake Mead. How is electricity made from water? Somehow, the kinetic energy in the water flowing through the dam has to be changed into electrical energy. The water will have to give up its energy to a machine. A circular motion is the best for powering machines, but the water is traveling in a straight line. The answer is a turbine. People have used water wheels to take energy from moving water for more than 2,000 years. Electricity firsts. The world's first hydroelectric power station opened in 1882 on the Fox River in Appleton, Wisconsin. It produced just enough electricity to light the power station, the home of the man who built it, and a nearby building. Today, nearly a fifth of all the electricity generated all over the world is hydroelectricity. What does a turbine do? A turbine looks like a drum with blades or paddles sticking out all around it. It works like a very fast water wheel. When moving water hits its blades, the water gives up some of its kinetic energy to the blades and they start moving. The turbine spins. The water's job is now finished. It flows out into the valley on the other side of the dam and continues its journey to the sea. Turbines work like ancient water wheels, but turbines are designed to work with much faster flowing water. Blades. Did you know? The Itaipu hydroelectric power station is one of the biggest in the world. It stands in the Paraná River, on the border between Brazil and Paraguay in South America. A line of 20 penstocks, huge pipes, guide water to its turbines. About 182,000 gallons, 690,000 liters of water rush through each penstock every second. That is enough to fill more than 30,000 baths every second. Generating electricity. The spinning turbine powers a machine called a generator. The generator's job is to change the kinetic energy of the turbine into electrical energy. How does a generator work? A generator makes electricity by using magnetism. When a wire moves near a magnet, magnetic forces make an electric current flow along the wire. A generator has a magnet in the middle that can spin. The magnet has coils of wire wrapped around it. When a turbine spins the magnet inside the wire coils, magnetic forces make an electric current flow through the wire. The turbine hall of a hydroelectric power station has a row of generators driven by spinning turbines below them. Electricity firsts. The electricity generator was invented in 1831 by an English scientist, Michael Faraday. He built a small working model. But it was a Frenchman, Hippolyte Pixii, who in 1832 built the first generator that could produce enough electricity to do useful work. An electric current flows out of a power station's generators. The energy's journey has taken one more step. It is changed from potential energy into kinetic energy, and now it is changed into electrical energy. A hydroelectric power station uses the energy in moving water to make electricity. Reservoir, dam, transmission lines, generator, penstock, turbine. Did you know? The link between electricity and magnetism was discovered by accident. A Danish scientist named Hans Christian Ørsted was showing his students an experiment in 1820. Every time he switched an electric current on or off, he noticed that a magnetic compass needle nearby twitched. It showed that electricity and magnetism affect each other. This simple discovery made it possible to invent electric motors, generators, and other electrical machines. Other power stations. Most power stations do not work like hydroelectric power stations. The energy they change into electrical energy comes from burning coal or gas instead of from flowing water. The burning fuel heats water to make steam. Then the steam spins a turbine, which powers a generator. Nuclear power stations use the heat from a fuel called uranium, but they do not have to burn the uranium. Uranium is made of big atoms that split apart easily. When they split apart, they give out a tiny burst of heat energy. They also send out particles that split more uranium atoms, making more heat. The heat is used to make steam that drives a turbine and generator. Power stations that use steam to make electricity work like giant kettles. Renewable energy. Wind, waves, sunlight, and other natural processes contain energy that can be changed into electrical energy. These are often called renewables because they are constantly renewed by nature. Now we have electrical energy, but it is not where it is needed. The next step is to move the energy to the places where people can use it. The spinning blades of a wind turbine power a generator in the cabin at the top of the tower. Spinning blades, generator, tower. Did you know? The world's biggest wind turbines are giants. Some of them stand 650 feet, 198 meters high, and their blades are 417 feet, 127 meters across. Each of these wind turbines can supply enough electricity for 5,000 homes. The turbine and the massive concrete block it stands on weigh 6,600 tons. How is electricity moved around? The electrical energy from a power station is moved to where it is needed by sending it along cables called transmission lines. As the electric current flows along a transmission line, some of its energy changes into heat, which escapes into the surrounding air. Less energy is lost in this way if the electricity is at a very high voltage. But if the voltage is too high, the electricity can flow out into the air. So, electricity is sent along transmission lines at more than 100,000 volts, but less than 2 million volts. The cables that move electrical energy from place to place are strung between tall metal towers. These keep the cables at a safe distance above the ground.